Good morning, all of you. Welcome to Sri Jayendra Rank Zone. Now, we are going to discuss lecture 5 in carbon compounds, that is 14 group elements. And in this, we are going to continue with allotopes of carbon. So now we are going to discuss allotopes of carbon now. So please listen carefully. It will be shared on your screen immediately. So now we are going to discuss compounds of carbon. So we have done already allotopes of carbon. Now we are going to discuss compounds of carbon. So what are the allotopes we have discussed so far in the previous lecture? We have discussed about diamond, graphite, and Buckminster following. Now we are going to discuss about compounds of carbon. The two important compounds of carbon are its oxide, that is carbon monoxide. It is neutral in nature. Carbon monoxide is neutral in nature, and the carbon and oxygen in the form of C triple bond O. It is C triple bond O. And the carbon dioxide is acidic in nature. Carbon dioxide is acidic in nature. So the structure is C double bond O, double bond O. So this is the four valency of carbon. So this is neutral in nature. Now we are going to discuss about the oxides of carbon, that is carbon monoxide and carbon dioxide. Let us continue now. So carbon monoxide, it is prepared by the direct treatment of carbon in limited supply of oxygen or air. It is prepared by the direct treatment of carbon in limited supply of oxygen or air. It forms carbon when combines with oxygen. In the limited supply of air, it forms carbon monoxide. Pure carbon monoxide can also be prepared in the laboratory by the dehydration of formic acid with concentrated sulfuric acid at 100 degrees C. So formic acid at 100 degrees C, it forms carbon monoxide and water. Formic acid is an organic compound. So pure carbon monoxide is obtained from formic acid in the presence of concentrated sulfuric acid. Concentrated sulfuric acid is also dehydration. Means what? Concentrated sulfuric acid is a good dehydrating agent. It absorbs water. It absorbs water. That's why it is called dehydration. So from formic acid, if you remove water, it forms carbon monoxide. It forms what? Carbon monoxide, and that can be done at 100 degrees C and with the help of concentrated sulfuric acid. So this is called preparation of carbon monoxide. And carbon monoxide is neutral in nature. Commercially, it is manufactured by passing steam over red hot coke. Steam is nothing but water. It is over red hot coke. Carbon monoxide is obtained as a mixture along with hydrogen gas. It is also called as syngas. This water gas is also called as water gas. So carbon red hot coke when on reaction with steam at a temperature of 200 to 1000 degrees C, it forms carbon monoxide and water hydrogen gas, which is also called as commercially it is called as syngas or water gas. Next continuation. Carbon monoxide is a colorless, odorless, water insoluble gas. Water insoluble gas. It is water insoluble gas. It is a good conduct. It is a good reducing agent and is used in metallurgical. Since this is very important use of carbon monoxide. It is used as a reducing agent in the extraction of metals, that is used in metallurgical operations to reduce metal oxides to metals. For example, ferric oxide is reduced to iron by the means of carbon monoxide. So carbon monoxide, it forms carbon dioxide. The structure of carbon monoxide is like this: C triple bond O with one unpaired electron for both oxygen and carbon. Because carbon has tetravalency, so only three it is forming. Oxygen is having oxygen 6 electrons, so it is forming like this, and with 2 electrons extra, two unpaired electrons. That's why carbon monoxide is also paramagnetic. And since it contains triple bond, it contains one sigma and two pi bonds are present along with a lone pair of electron on carbon. So with a lone pair of electron on carbon, therefore CO molecule acts as donor and forms complexes with certain metal called metal carbonyls. As I told you, metal carbons, NaCO taken 4 times, complex compound. Iron carbonyl, FeCO taken 5 times. This is also complex compound. So the toxicity of CO is due to this, as it forms complex with hemoglobin, restricting the transport of oxygen. So if we inhale carbon monoxide, it's very poisonous in nature because as it forms complex with compounds, hemoglobin contains iron, it forms iron carbonyl compound. which restricts the transport of oxygen, and it combines blood. It combines with blood, and due to which what happens? It is very fatal for human. So if you inhale carbon monoxide for 10 minutes also, the person will die. So the toxicity of carbon monoxide is due to this reason, that is complex formation with hemoglobin restricting the transport of oxygen. So it combines the blood and forms carboxy hemoglobin. What is it forms? Carboxy hemoglobin, which is very dangerous because oxygen will not be supplied to the blood. So due to which what happens, the person will die. Next preparation is carbon dioxide. It is prepared by the complete combustion of carbon in excess of oxygen or air. Complete combustion of carbon forms carbon dioxide. Partial combustion of carbon will form carbon monoxide. So it combines with methane. Methane, when combines with oxygen, it forms carbon dioxide. Any organic compound, I'll write here simple word. This word we have used also already. Any organic compound when burns in air oxygen, it forms carbon dioxide in water. Any organic compound, any organic compound when burns in air, when burns in air, any organic compound when burns in air, it forms carbon dioxide and water as the major products. So methane when burns in air, it forms carbon dioxide and water. Any alkane, alkene, alkyne, benzene, any organic compound when burns in air, it forms carbon dioxide and water. So carbon dioxide is prepared from organic compounds as well as direct combination. In laboratory, it is prepared by the action of calcium carbonate, action of dilute HCl on calcium carbonate. Dilute HCl and calcium carbonate combines together to form calcium chloride, carbon dioxide, and water. So in the lab, it is prepared by this method. On commercial scale, it is heated by the means of limestone. By heating limestone, when limestone is heated strongly, it forms calcium oxide solid and carbon dioxide gas. So these are the main methods of preparation of carbon dioxide. Continuation now. Carbon dioxide is a colorless, odorless gas. It is not a supporter of combustion, hence it is used in fire extinguishers. Very important point is carbon dioxide is not a supporter of combustion. It is not a supporter of combustion. That's why it is used in fire extinguishers. So it is soluble in water to exist in forming carbonic acid, H2CO3. H2CO3 forms a buffer system due to the existence of HCO3 minus along with H2CO3 in solution. It helps in maintaining pH of blood. So it is 7.26 to 7.42, the pH of blood. Carbonic acid being acidic reacts with alkalis to form metal carbonates. And moreover, carbon dioxide is acidic in nature. So carbon dioxide is acidic in nature and carbon monoxide is neutral in nature. It helps in maintaining pH of blood. This is carbonic acid being acidic reacts with alkalis to form metal carbonates. Continuation. In carbon dioxide molecule, the carbon atom undergoes what hybridization? It is undergoing sp hybridization. Doing what? Sp hybridization. So carbon atom is undergoing sp hybridization. The p-pi bonding prevails between carbon and two oxygen atoms. The CO bond length is 115 picometers. It has zero dipole moment because opposite dipoles cancel out each other. Its greater stability can be explained by its resonating structure as well. So C double bond O, double bond O. This is the structure of carbon dioxide. Its shape is linear. What is the shape of carbon dioxide? Linear shape. Uses. Carbon dioxide is useful for the process of photosynthesis. It is useful in the process of photosynthesis. Carbon dioxide as a solid is called dry ice and is used as refrigerant. So dry ice, it is used as refrigerant in cold storage. Carbon dioxide is strong non-supporter of combustion and it is used in fire extinguisher. Is used in fire extinguisher. When sodium bicarbonate is burnt, fire extinguisher consisting of sodium bicarbonate. When it is burnt, it forms sodium carbonate along with carbon dioxide plus water. This carbon dioxide coming out from the fire extinguisher will put off the flame. That is because carbon dioxide is a non-supporter of combustion. It is a non-supporter of combustion. So that is why carbon dioxide is used in fire extinguisher in the form of sodium bicarbonate. When you heat sodium bicarbonate, so sodium bicarbonate, when you open the fire extinguisher, that cork, automatically carbon dioxide will come out of it, and this carbon dioxide will put off the flame. Very, very important. Next continuation. So now I'm going to discuss questions based on carbon compounds. Please listen carefully, all of you. So I'm giving new slide share. Yes, now questions based on carbon compounds, MCQs. MCQs based on carbon compounds. Let us start now. So question number 1, based on carbon compounds. Writing it now on the board. Please make a note of all these questions because these questions are not given in this. Given the parts formed by the hydrolysis of aluminum carbide. Give the question number 1. Give the products formed by the hydrolysis of aluminum carbide and calcium cyanamide. Aluminum carbide. So option A, it is aluminum hydroxide and ethane gas. Option B, it is aluminum hydroxide and methane gas. Option C, it is aluminum hydroxide and carbon dioxide gas. And option D, it is aluminum hydroxide and carbon monoxide. So in all, aluminum hydroxide is common. So definitely aluminum hydroxide will form. So apart from that aluminum hydroxide, what is formed? It is methane. That's why this aluminum carbide. So both beryllium carbide and aluminum carbide are called as methanides. Next question number 2. Question number 2 right now. Identify the incorrect statement. Identify the incorrect statement. Identify the incorrect statement. Identify the incorrect statement. First option, diamond and graphite are two allotropes of carbon. Diamond and graphite are two allotropes of carbon. Statement 2 is B. In diamond, each carbon is sp3 hybridized. In diamond, each carbon is sp3 hybridized. sp3 hybridized. Statement number 3. Statement number 3. In graphite, each carbon is sp2 hybridized. In graphite, each carbon is sp2 hybridized. Statement number 4, that is option D. Graphite shows high electrical conductivity in one direction only. Graphite shows high electrical conductivity, electrical conductivity in one direction only. In one direction only is the fourth option. Graphite shows high electrical conductivity in one direction only. So these are the four options we have. This is question number one. So answer is definitely it is fourth option because graphite shows electrical conductivity, but it is not in one direction only. So answer is D. So question again I'm showing it. Please see. Diamond is and graphite are two allotropes of carbon. It is 100% right. In diamond, each carbon is sp3 hybridized. It is also 100% right. In graphite, each carbon is sp2 hybridized. It is sp2 hybridized. This is also 100% correct. And graphite shows high electrical conductivity in one direction only. It is not correct. So answer is option D. Now question number three. Question number three. Now the average value of CC bond order in graphite is the average value of the average value of CC bond order. The average value of CC bond order in graphite is option A. It is 4 by 3. Option B. It is 3 by 4. Option C, it is 3 by 2. And option D, it is 1. So what is the average bond order of CC bond order of graphite? It is equal to 1.33 since already we know it. So answer for this, it is 1.33. So average bond order of graphite is equal to average bond order of graphite is equal to 1.33. So which will come 1.33. So it is nothing but 3 by 4. Option A. 3 by 2 or 3 by 4? 3 by 2 means again 1.5. So it should be 4 by 3. Option A. So answer is option A, 4 by 3. Next question. Question number 4. Yes, question number 4. Fire extinguishers. Fire extinguishers. Fire extinguishers contain a bottle of contain a bottle of H2SO4, that is sulfuric acid and option A, it is calcium carbonate. Option B, it is magnesium carbonate. Option C, it is sodium bicarbonate. And option D, none of these. So easily you can say the answer. It is nothing but sodium bicarbonate. Just now we discussed in fire extinguishers, sodium bicarbonate is there. From this sodium bicarbonate, it releases carbon dioxide, and this carbon dioxide, non-support of combustion, puts off the flame wherever fire is being erupted. So this is called carbon dioxide. Next question, question number 5. Question number 5. Let us see now. Carbon monoxide is absorbed by carbon monoxide is absorbed by option A, alcohols, option B, plants, option C, plants, option C, ammonical ammonical cupus sulfate, cupus chloride solution, cupus chloride solution, and option D, it is nickel tetracarbonyl, nickel tetracarbonyl, nickel tetracarbonyl. So right answer is carbon monoxide is easily absorbed by ammonical cupus chloride solution, plants, alcohols, and final option is it is nickel tetracarbonyl. So answer is 48th one. So answer is third option. It is ammonical cupus chloride solution absorbed. Next question number 6. That's why we are discussing questions because we get new points from the questions. Next question. Structure units of question number 6. Which of the following halide of carbon? Which of the which of the which of the following halide of carbon? Which of the following halide of carbon is which of the following halide of carbon is used as refrigerant? Refrigerant. Option A, it is CCl4. Option B, it is CF4. Option C, it is C2O4. Sorry, CH2Cl2. And option D, it is CCl2F2. So which of the halide is used as carbon halide is used as refrigerant? So uses also sometimes it is important. They'll ask uses also questions. So it is very, very important. So answer is CCl2CF2. It is also called as Weston. It is answer is what? CCl2Cl2, CCl2F2. Also called as Weston. Common name is Weston. So it is used as refrigerant. It is used as refrigerant. Next question, question number 7. Question number 7, please note it down. Graphite is soft lubricant, extremely difficult to melt. The reason for this anomalous behavior is graphite is. So graphite is used as lubricant because of its graphite is used as a lubricant due to option A, non-crystalline substance. It is a non-crystalline substance. Due to non-crystalline substance, option B, it is an allotropic form of carbon. Due to allotropic form of carbon. Option C, it has molecules of variable molecular masses like polymers. It has molecules of variable molecular masses, like polymers. And option D, due to its soft and slippery nature of layers. slippery nature of layers of its layers. It is used as, so answer easily you can say that is due to its soft and slippery nature of its layers, it is used as lubricant. Graphite is used as lubricant due to its soft and slippery nature of its layers. Very, very important question. Next question number 8. Question number 8. Let us see now. So all these questions are very important. Now question number 8. Question number 8. Let us start now. Question number 8. Carbon 60. Carbon 60 can be regarded as huge ball, can be regarded as huge ball, huge ball made up of, made up of, made up of, huge ball made up of. Option A, several several conjugated alkenes, several conjugate alkenes, several conjugate alkenes units rather than aromatic molecule, units rather than aromatic molecule, aromatic molecule. Option B, it is graphite units, several graphite units are kept inside. Option C, it is several aromatic benzene molecules, several aromatic benzene molecules. And option 4, it is several tetrahedrons, several tetrahedrons. So these are the 4 options we have. So it consisting of several aromatic benzene rings. Third option, fourth option, several tetrahedrons. So C60, carbon C60, it is also called as Buckminster following. It is regarded as several conjugate alkene units rather than aromatic molecules. So answer is first option. Several conjugate alkene units rather than aromatic molecule. That is called Buckminster following. So please make a note of it. Now question number 9. Question number 9. Carbogen. This question is very important. Carbogen is given to pneumonia patients. Pneumonia patients. Carbogen is given to pneumonia patients. It's given to pneumonia patients and victims of carbon monoxide poisoning and victims of carbon monoxide poisoning. As a, it is a mixture of. So first option, mixture of oxygen with 5 to 10% carbon dioxide gas, mixture of helium, mixture of helium with this is helium, mixture of helium with 5 to 10% carbon dioxide gas, mixture of oxygen with 20 to 30% carbon dioxide gas, mixture of oxygen gas with mixture of oxygen with 20 to 30% carbon dioxide gas, and fourth option finally, mixture of helium. Mixture of helium. This question is very important. Mixture of helium with 20 to 30% carbon dioxide. 30% carbon dioxide. So carbogen is given to pneumonia patients and victims of carbon monoxide poisoning. Carbogen is given to pneumonia patients and victims of carbon monoxide poisoning, and this is given to the patients which are suffering from pneumonia as well as carbon monoxide poisoning. And for this, what is the mixture they are giving for treating that type of patients? So it's very important. So the first option is mixture of oxygen with 5 to 10% carbon dioxide, and second option, mixture of helium with 5 to 10% carbon dioxide. Since pneumonia patients are having lung infection, so they have breathless problem, they have breathing problem. So pneumonia and carbon monoxide poisoning, they have what problem? Breathing problem. So to avoid that breathlessness, breathing problem, so to avoid that breathing problem, they will be given mixture of oxygen gas with 5 to 10% carbon dioxide so that they can be cured properly. So the answer is first option. Mixture of carbogen is a mixture of oxygen with carbon dioxide, 5 to 10% carbon dioxide. Very, very important question. So mixture of oxygen with 5 to 10% carbon dioxide is called as carbogen. Next question. Question number 10. Just make a note of it. Very, very important question that is. Which are the following oxides? Which of the following oxide is neutral oxide? Option A, it is carbon dioxide. Option B, it is silicon dioxide. Option C, it is carbon monoxide. And option D, it is carbon suboxide, C3O2. So answer for this straight away, we can say carbon monoxide is neutral in nature. Carbon monoxide is neutral in nature, whereas carbon dioxide, silicon dioxide is acidic in nature. Carbon suboxide is also acidic in nature. So carbon monoxide is neutral in nature. Next question. Based on carbon suboxide, so the number of sigma bonds and pi bonds present in carbon suboxide is option A. Number of sigma bonds and pi bonds present in carbon suboxide is option A, 4 sigma 5 pi bonds. Option B, 4 sigma bonds and 6 pi bonds. Option C, 6 sigma bonds and 4 pi bonds. And option D, it is 4 sigma bonds and 4 pi bonds. So right answer we have to check. So for this you should know the structure of carbon suboxide. It is C3O2 structure. Yes, let us see now The structure of C3O2 is O double bond C, double bond C, double bond C, double bond O. This is the structure of carbon suboxide 1, 2, 3, 4. So O double bond C, double bond C, double bond C, double bond O. This is the structure of carbon suboxide. So it is C3O2. So it has 1 sigma, 1 pi, 1 sigma, 1 pi, 1 sigma, 1 sigma. Total 4 sigma, 4 pi bonds. Because it has 4 double bonds. On the top it is 1 sigma, 1 sigma, 1 sigma. And the base it is 1 pi, 1 pi, 1 pi. Because for double bond we have 1 sigma bond, 1 pi bond. So definitely it has 4 double bonds. So it has 4 sigma, 4 pi. Answer is what? 4 sigma bonds and 4 pi bonds. Very, very important question. Like these questions are important for examination. And even they can ask the oxidation state of carbon is carbon suboxide. Oxidation state of carbon. Oxidation state of carbon in carbon suboxide is in carbon. This is also they can ask in examination. Carbon suboxide is, what is the oxidation state of carbon in carbon suboxide? So carbon oxidation state means, let us say it is 3x minus 4 is equal to 0, because so 3x is equal to 4, so implies x is equal to 4 by 3. X is equal to how much? 4 by 3. It is a fraction. Is a fraction. The oxidation state of carbon in carbon suboxide is, because 2 oxygens minus 2 into 2 is 4. So 3x minus 4 is equal to 0. So as there is no say of peroxides, so we can write straight away C3O2 structure is like this. Number of sigma bonds and pi bonds is 4 sigma bonds, 4 pi bonds. Very, very important question. Next question. Question number 12. Question number 12. Like these questions are very important for examination point of view. Moderate electrical conductivity. Moderate electrical conductivity. Modern electrical conductivity is shown by option A. It is silica. Silica means silicon dioxide. Option B, it is graphite. Option C, it is diamond. And option D, it is carbonum. So carbonum is not a compound, it's an ore. So answer straight away blindly you can say it is graphite. Moderate electrical conductivity is shown by graphite. Next question. Question number 13. Question number 13. With respect to graphite and diamond, with respect to graphite, with respect to graphite and diamond, with respect to graphite and diamond, which are the following statements is given? Which are the following statements? Which are, as I told you, statement-based question with respect to graphite and diamond is important. Which of the following? Which of the following statements is are correct? It is multiple choice questions, not single correct. It is more than one correct option. So please make a note of it. Graphite is harder than diamond. Graphite is harder than diamond. That is option 1. Option 2, that is second option B. Graphite has higher electrical conductivity than diamond. Graphite has higher electrical conductivity than diamond. Next, option C. Graphite has higher thermal conductivity than diamond. Graphite has higher thermal conductivity thermal conductivity than diamond. And option 4, graphite has higher CC bond. Graphite has higher CC bond length. CC bond order, not bond length, than diamond. So what is the right option? Easily can guess because we have discussed enough points based on diamond and graphite. So answer is graphite has higher conductivity than diamond. Graphite has higher thermal conductivity than diamond. Graphite has higher CC bond order than diamond. So answer is B and D or BCD. So it is answer is BCD. Answer is what? It is B and D only. So it is B and D because higher thermal conductivity only. So answer is only B and D. Only B and D. This is multiple choice answer. B and D. It is not right option. So answer is only B and D. C is option is wrong. So B and D answers are correct. Graphite has higher electrical conductivity than diamond, and graphite has higher CC bond order than diamond because the bond order of diamond is 1 and CC bond order for graphite is 1.33. Whereas for diamond it is 1 only. For diamond it is 1 and for graphite it is 1.33. So it is higher than, so this is graphite. This is CC bond order. CC bond order for graphite is 1.33 and for diamond it is 1. So answer is B and D. So this is statement based question. Definitely you'll get questions based on statement based question only from diamond and graphite. So next question. So with this, we have discussed many questions based on diamond and graphite and even carbon dioxide, carbon monoxide. In the next session, we'll come up with silicon. Silicon is most important in this chapter. As I told you, 13th group, boron is important. And like that, in this group, silicon is important. So with this, I'm ending this session. Thank you all.